In this video, we will focus in on how to write a question, a hypothesis, and remember what we learned about independent and dependent variables. Let's begin with a question. To write a question like a scientist, we think that the question usually begins with will, and it follows by what we are changing. We call that change that we are changing the independent variable. That's what we choose to change. The next part of the question includes what we are measuring. And what we measure is the dependent variable. Here's an example of a question. Will adding weight to a paper helicopter change how quickly the helicopter falls? Do you see what we're changing? Can you find what we're measuring? Let's look at it again. In this slide, we are going to change what we are measuring in red. That's the independent variable. We are going to look to see what we are changing and what we are measuring, and we are going to think about that as the dependent variable in yellow. So here's the question again. Will adding weight to a paper helicopter change how quickly the helicopter falls? Think about what the independent variable would be, what we're changing. Did you decide it was adding weight? Good job. We are adding weight to the paper helicopter. Well, what will show us what we've done? What will be the dependent variable that we're measuring? You got it. It's how quickly the helicopter falls. And we can measure that in units of time. Let's take a look at 3 more examples. Will an Energizer battery, Duracell, or Rayovac battery last longer? What would our independent variable be? You got it. It's all these batteries. We're changing brands. So I listed the brands in the question that I wrote. What am I going to measure? What will my dependent variable be? If you chose last longer, you got it, because I'm going to be able to measure that in units of time. Look at the second question. Will there be fewer unpopped popcorn kernels if the popcorn is cooked longer? What would the independent variable be, or what I'm changing? This one's a little bit different because there's nothing specifically in the question. But if you look here, fewer unpopped popcorn kernels if it is cooked longer. What am I changing here? I'm not changing the fewer unpopped popcorn kernels. That's what I'm measuring. What I'm changing is the time. I'm changing how long I put that popcorn in the microwave. What I'm going to be measuring is fewer unpopped popcorn kernels. So I'm going to measure that with a number. All right, let's take a look at the next question. Will the car go farther down a ramp if it weighs more? What am I changing? This was tricky too because weighs more is here. But what am I measuring? Farther down a ramp. So you can see questions aren't always written to where you have to have the independent variable first and the dependent variable last. The most important thing is that both are there and it's obvious what they are. Now let's look at hypothesis. When we're looking at writing a hypothesis, it's something a scientist does before beginning a test, and it's usually written in a pattern. The hypothesis always starts with if, because we haven't done it yet, and adds in what you are changing. Oh, and there we go. It's that independent variable again. The hypothesis continues with adding what you are, oh my goodness, measuring, because that is the dependent variable. Now it's very important to have a word that includes what I am measuring because that's what shows what I am testing. If I used words like it will taste better, or I will have more, or it will win, those aren't measurable qualities. I want to have a really great measuring word, so it's obvious what I'm measuring. It could be time, it could be length, it could be distance, it could be number of things, but it definitely has to be something measurable. Let's take a look at what my helicopter hypothesis might have looked like. If weight is added to a paper helicopter, then the helicopter with more weight will fall faster than one without weight. Here we go. If weight is added, that is my independent variable, what I'm changing. If I'm looking at what I'm going to be measuring, it will fall faster. So again, I'm making sure that my variables are obvious in my hypothesis as well. We did the first example on the first slide. Now let's look at the second example, the one that we can see right here. If weight is added to a paper helicopter, then the helicopter with more weight will fall slower than one without weight. My independent variable is what I'm changing. Weight added to the helicopter. My dependent variable is what I'm measuring. Fall slower. Now you'll notice that these two are different. This one says fall faster. This one says fall slower. A scientist uses their hypothesis to make a prediction. So a hypothesis should always indicate what you think is going to happen. Do you think that scientists are always right? No. In fact, really great scientists are usually wrong. It takes a very long time for them to be right. They use their mistakes to make different hypotheses and to change how they're testing things. So don't be afraid to be wrong. It's okay. In fact, you probably learn more if you are. Now let's practice some more. I have two examples here and a half of another one that we're not going to worry about. The first one says, if I place an Energizer battery, a Duracell battery, and a Rayovac battery in a flashlight, the Rayovac battery will last longer. My independent variable is what I'm changing, and here it is. All these batteries. I'm changing the brand. And what am I measuring to test? Lasting longer. Again, I'm using time. Now let's look at that tricky popcorn one. If I place a bag of popcorn in a microwave for 2 minutes, another for 3 minutes, and another for 4 minutes, the popcorn cooked at 4 minutes will have fewer unpopped popcorn kernels. Just by reading that, I can see that this is so much more obvious what I am changing. My independent variable is listed here, all these times. So I'm changing the amount of time I put the popcorn in the microwave. And now I can see what I'm measuring here, fewer unpopped popcorn kernels. So when we look at a hypothesis, it's a little bit more specific than a question. Here I'm going to have my independent variable in the first part of my hypothesis and my dependent variable with my opinion or what I believe to be true in the second part of the hypothesis. So let's look at what we've learned. We've learned about questions, we've learned about independent variables, and we've learned about dependent variables as well as a hypothesis. Look at this question. Will a pillow weigh more as they age? What do you think the independent variable is? Let's take a look at the question here. Will pillows weigh more as they age? So what I'm changing is going to be the age of the pillow. So it might take me a long time to find out if this process or if my hypothesis is right, because I've got to wait for time. That's what I'm changing. My dependent variable is going to be the weight of the pillow. So I'm keeping the pillow the same. That would be a control. But as the pillow ages, that's what I'm changing. I can measure to see if my hypothesis is true. Now, one thing that sometimes people get really confused is independent and dependent variables. So here's a little trick on how to remember them. I think of the independent variable is when I am independent and I'm in charge and I choose what I change in my science project. That's what I'm changing. Independent, the one thing I am changing. For dependent variable, I think, well, I depend on someone and I count on them. And I'm going to count on my dependent variable to be able to show me if I was right or if, as a scientist, I was wrong. And the only way I can check to make sure I'm absolutely right or absolutely wrong is by measuring something. So scientists, you're starting your STEM Fair project, and I hope that this video helped you understand the difference between a question, a hypothesis, and all of those variables. Please don't hesitate to ask your teacher if you need any more assistance.